Brian here from quantlabs.net. I'm going to be showing you our first, I won't call it a sophisticated, well, it is a sophisticated step. The March 2 and HFT, or high frequency trading platform, continues. There's a number of things I am going to show you in this video. First, I'm showing you, I've already done this numerous times, is the Rcpp inside, the Rinside, where it enables you to have your C++ program call an R program from within the C++ source. So I've done enough videos on that. I've done enough videos on the setting up of this Linux environment that you're looking at, my VirtualBox in Ubuntu. I'm also using NetBeans as my IDE, or integrated development environment. Everything's all set up with a compiler and stuff, so I'm not going to get into that. The goal of this video is to show you the performance of using real-world market data that I've downloaded through IQfeeds. I've got 3 samples I'm going to show you. The very first one's a very simple Google historical data file. It's using 1 minute of data. It's got over 62,000 observations in it. It's fairly fast. After that, I'm going to show you another 1 minute file of Apple, and that one's got over 1 million observations in that file. And the last one I want to show you is another tick history, or not tick history, tick data of Procter & Gamble, and that's got over 1 million as well. So I just want to show you the performance of each, that this can be done. And I'm also going to walk you through a very simple it's not really an R script, just really 3 R statements that I'm going to be calling. And really all I'm doing is I'm sending over either the bid price from the tick file or the closing price from the historical data, and processing the returns for whatever that time series is. That's all I'm doing. I'm going to build a little more sophisticated R script code from within the C++. Probably do something like an ARIMA, or maybe even fool around to see if I can source out an R script from within C++, because I'm fairly new with the R inside. I'm not sure what the limitations are. So far I haven't seen anything, but there are some things that I'm kind of questioning in terms of trying to understand it, and as you know, it's all about playing with it. So by watching this video, I'm hoping I can cut down your time instead of me wasting 10-12 hours on each time it takes me to prepare my final results, which is what you see in the video. Okay, so what I got here in my terminal, this is my Linux terminal, obviously. I'm inside the R package that you download from, I believe it's CRAN or wherever you download R inside from. It's the install examples under standard. There's a few things I want to show you as I understand it. Right now there's 5 different types of samples, I guess you could call them. The 3 that I want to focus on, and the one I will show you from is the standard. But let me talk a lot about the Eigen and Armadillo samples. Okay, if you're new to C++ or the world of it, it is kind of confusing even from my perspective, because there's so many matrices libraries out there, namely for algebra. There's LPAC, there's BLAS, and a bunch. And then there's different implementations of those, because those ones come from the world of Fortran. They're fairly mature. They've been out for many decades. I wouldn't be surprised that all major applications use those C libraries. But what's also happened is there's implementations of those that use those functions in their own implementations to even speed up the matrices calculations even faster. And that brings me to 2 that are, we'll call them sub-projects of Rcpp. There's Rcpp Armadillo and Rcpp Eigen. Some of the code that I'm going to show you is using the Rcpp Armadillo. I use that for now because it's easy to work with, it's easy to code, but it's slower from what I understand from another posting I've seen. the eigen is 25% faster than the armadillo. So I'm not too worried about that at this point. I just want to get things up and running and get it kind of quick and dirty. So what I'm about to show you is just using the armadillo code or the Rcpp armadillo. I'll show you that when I get to the code. So under the standard set of examples, there's a good bunch of examples in there. It just comes down to plotting or matrix manipulation or whatever. All the samples are there. They're fairly well documented and all that fun stuff. So what I've got here is I've got a NetBeans project within my workspace for the armadillo, imported it in and all that. Now I also have within that folder a custom, I guess call it a hacked C++ program that I've been playing with that does everything. So I'm going to walk you through that and try to show you what I've done to do this. All right, so let's just go look at the main function for now. So here's the main function. This C++ is from another resource that I've grabbed. So some of this code has been referenced for that source. But all we're doing, I'm just going to really walk you through it real fast. And this code is available for my premium members. But as I said, the real purpose of this video is to show the speed differences when I use the different types of files. All right, but let me just at least give you a brief overview of how the code works. Okay, so we've got a data type data in here in the main function. We do a data load based upon this custom file name. Now again, these files that I've downloaded, now again, these are real world market tick data or historical data from IQfeed. There's commercial software that's available. I've got again, I've done enough videos on this. I've got webinars I've done on this in the private membership or in the premium membership. So this is done. I don't want to have to rehash all this. But again, this is all market data. Now, how do I know which is which? It's very simple based upon this underscore whatever. The underscore 1 is a 1-minute historical database. Obviously, this is a tick database. I just named it that just for fun. It's Procter & Gamble. It's tab delimited. All these are tab delimited. Okay, and I'll show you the code that will show and display the size of the time series as it gets sent over to R from the C++. Of course, using rinside. So, as I said, that's the data that we're working with. We are now loading it. Let me just give you a very fast overview of that function. Okay, so we load it. We stuff it into a deck or a DQ, and that's all we're doing. We're just adding it to a local deck. Okay. What does that look like? That's it right there. We got different custom load and save different functions with different typecasts for parameters and all that. Alright, so we load it in, and then we now are going to save it. Okay, this is from this custom our C++ program that I've got somewhere. I've got the references as usual. If you remember, it's always at the top. Usually, yeah, somewhere. I'll make sure I got that referenced because that person deserves the credit. Okay, so we've got that, and all the action happens in that save function. So let's go to the save function. Here we are. Okay, so we're using this OStream output. Got a double here. Okay, now this closes is really our a dynamic pointer based upon the size, number of times in that time series that we download or that we captured from the file. Okay, that's what that is. That's what the closes is. Okay, so we've defined a local size integer and all that. So what we're going to do is we're going to now create our new closes dynamic integer array, and we cycle through, iterate through our file, or sorry, our this what do you call it, record iterator, yeah, our data, and that's locally stored in this, so it cycles through it, and then it will go in and it will build, it'll extract, because this is one big table of different fields, because it's tab delimited, right? So for the historical, we are needing the 5th column. Okay, that's just how the file is structured. If you need to see that, I'll show you the simple one, which looks like this. So let me pull it up in my Excel. Okay, so you probably won't be able to see this, but Excel's loading. This is in my local desktop. So here's what the file will look like. So we're going to cycle in 5 columns, 0, 1, 2, 3, 4, 5, or 0 offset, and it's going to use this close price. So that's why it's 5th. Now, if it's a tick database, now this is going to take a while for it to load up because it's pretty massive. So let me load up the tick database. Sorry, the tick file. And let me just give me a second. I'll show you that one as well. Now, when I'm again loading up the tick database, I'm going to show you the format of that one. You can probably see it right here. Now, again, I've shown you past videos on how to do this. It's part of my membership. And all this can be generated within 9 seconds. I think I even showed it on my YouTube channel somewhere, but I'll let you figure all that out. So obviously, again, from IQfeed, this tick database is totally different format, but actually it's going to grab it from here. I'm using the bid, so 0, 1, 2, 3, 4, 5, 6. Okay, yeah, all right, and let me just go back to my code in the Linux. Hang on here. Okay, so now that you understand the format of the files, so we have 5, column 5 of that table or array, and that will be the close price, and if it's tick data, it's a 6th column. So for now, it's a 6. It's a 5th column because we're gonna play with this historical table. Okay, so now we're gonna extract the 5th column out of that record iterator, and generate a new index for that closes array, that dynamic array, and we're going to have that little counter of the size of the time series. Okay, so once it goes through that complete record iterator is finished, basically I just printed out a little, a little statement saying how big is that time series, this size right here. All right. So now we're going to get into the fun stuff with the R. Okay, I believe I've given reference of where this set of code comes from. I believe it's a 4th. Yeah, it's a 4th sample of those files I just showed you in the terminal in here. And let's get to that fun stuff. Okay, so we're going to create a vector. This is again from that sample. And that's to be used for the armadillo, the Rcpp armadillo. Oh, I forgot a very important statement here. We got to create our embedded R instance within the C++. Okay. Now you're going to ask yourself, what's all this wonky code here for? I'm still trying to build a cleaner, more efficient way of doing this, but all I did was just being The quick and dirty kind of person I like to be, I guess. I've got here argc, argv, because normally the code examples will be called from the main. In this case, I'm just doing them from another function, which is that save one, and I'm just putting in some dummy data and allow it to compile. Okay, so there's that. We create our new vector called CL. Yeah, we predefined it based upon that size I just showed you a little bit ago. Now, this is our first R statement. So right here, we're creating a new matrix. Actually, it's a vector, I believe. A vector in R. Okay, this is going to reside in R. The CL close of VEC is a matrix within from that's being assigned from or instantiated from the C++ CL, which is generally this we just created. So we create this CL vector, and this is from basically copying it from the closes or instantiated from the closes, which is from this guy right here. I hope you're still with me. And that's been extracted from the massive data file on the 5th column that I showed you earlier. All right, so good thing about YouTube, you can always rewind and review so you can understand it. All right, so we've created our first R object, CLVEC. So now we're going to predefine or define our statement of R. Okay, so there's two different ones. I'm just going to leave this one for now. I'm just saying this is going to say I'm in R. Like when you see that, that's an R call. C++ is now calling R. So that's calling R. These quotes right here, or what's in the quotes. And here's another R sample code. So I'll just put a cat in there to display in R. Returns will be, okay, so we are now going to calculate our returns on that closing price, which is really in the closing vector within the as an R object. So we're just going to differentiate, log it, standard stuff that my members have seen, and that's it. So that's our text command, which is all in R. And now what we're going to do is we're going to create a new armadillo vector for C++. I know it gets kind of confusing, but if you watch some of the other, actually look at the sample code for the R inside, you get it once you see it. It's really straightforward. It's not that difficult. So this is our armadillo vector that we're defining or instantiating called V. And now we're going to call and run that our set of R statements that I showed you earlier here, these ones. At the same time, it's going to convert the vector, and at the same time run that these R commands. So again, when you see this in R, that means that this is being called, which is calling R itself. Okay. So once that's done, we need to delete. This could be pretty well anywhere, but again, this is just deleting the dynamic memory array closes. That's pretty standard. Release that memory. If you get a million observations, that can be pretty big memory. And if you don't do that, you're going to mess up your system. So now I've got another statement. We're going to do a cout in C++. So now we're back in C++ with that vector from R that we've created right here. This is really the V. And we're just printing out a message saying press a key. Okay. And now we press our key, woo, and now we're going to display the resulting vector from our RC++ or R call. And that's what's going to get generated. Now I'm going to manipulate this on the other files, but again, I just want to show you the code up front, walk you through it, so you can see it and understand what it's doing each time I'm running it. Now I'm going to do a build and clean. Recompile the whole project. Off she goes, clean, successful. The G++ is running to compile, and the linking right here. And we're done. Okay, so we're going to run this main bin file, which is no different than a win.exe file. Yeah, run it. Okay, so it's now running. It's calculating our, creating our closes table. So, okay, before we proceed, this is the size of our number of observations in that time series. So we have 62,000. Press a key in R. So this is right here's our R call, and now we're going to display our vector from R. So that's it. Okay, I'm going to break that. Okay, so I'm going to, like I said, I'm going to manipulate some of our calls here. I am going to take out that get character. Okay, I just want to show you the speed. I'm also going to take out this one as well. I just want to show you now the differences of the files that are being imported. Okay, and how long it takes to run each one. So let's run and do a clean and build, recompile, the fun stuff of R. Sorry, the fun stuff of C++. You always have to compile when you make a change. Okay, so she's almost done. Run it. She goes. So this takes a bit. Should take about 5 seconds to do the whole thing. Okay, so it took 6 seconds. Now, this is now 62,000 observations. Took 6 seconds. Is that a lot? Probably. Now what we're doing is essentially we're testing, we're bringing in market data from that file. I showed you the historical data file. If you need to know, I know it's a lot to chew on. But we're talking about this little guy right here, or this guy as well. Okay, that's our Google 1 minute historical database. So essentially it took 6 seconds to process. So what are we doing? We are creating an internal dynamic array in C++ here of 62,000 observations. Now what we do is we pass that to R. Okay, and once R will do its thing, and again that's just basically calculating the returns of those closing prices, and that passes it back to C++, and that takes 6 seconds. So now what are we going to do? We're gonna change it up from 62,000 observations to reading an Apple historical tick database. Let's see what happens here. Okay, so we comment this guy out. Okay, and we are now going to use this Apple historical database or historical data. Okay, now everything stays the same. The only difference is we're just going to keep our eye on to see how long it takes, number of seconds to do that. Again, we got to do a clean and build, and then we're going to rerun and see what happens. Now, if I remember, I'm going to show you the size. I don't want to tell you the time it takes, but okay, let's start running it. Okay. So we're doing the same thing as before, but just a different historical database, or historical file. So it's bigger. Okay, so here's the thing. Now remember, the last one was 62,000 observations, but this one is much, much bigger. It's 831,000 and change observations, okay? But it only took 8 seconds to run, okay? That's not too bad, okay? Because to be realistic, 800,000 observations, that's kind of realistic. Again, what we're testing is see how long does it take to do these type of operations. So 830,000 to do a calculation in R. Actually, again, let me just rewind. We create right here our dynamic integer pointer array. We pass it to R, okay, and then we get R repasses it back to C++, and it takes 8 seconds. That is okay at the beginning, okay. But again, this is real world market data. So now let's change it up. There's two changes we got to make for our tick data. So we're going to create, we're going to run our tick data. Okay. Hang on here. Yeah. Okay, so we got our tick data. We just uncommented. So that's what we're going to now play with the tick tab. But again, we got to make one other change. And remember, I said because now this is tick, we're going to use 6, the 6th column, not the 5th column, because now we're using tick data, not historical data. So that's the only other change we're going to make. Clean compile, clean and build, which again is doing that compile. And then we're going to run it. Now you'll see the difference here. Let me just load up that data again. Let me just run it. Okay. So off she goes. Now again, we're dealing with 1 million plus. I don't know exactly how many. It's just a little over 1 million observations. Okay. But you can see it's a lot slower. Again, this is tick data. It's not necessarily a compulsory thing you need to work with. So we're dealing with 1,048,000. Okay. Took us 19 seconds to do all that. So it is much slower, but let me just take a look at that file just to be fair to the situation here. I'm going to load up my Excel again. You get a lot more detail in this file formatting from IQfeed, so there might be some reasons for it. This is what I'm still trying to architect to see how to work this into a complete platform, or do I have different processes and that are independent? Yeah, I can see the problem already. Let me just... Okay, so we got our bid. Okay, so we got our bid, right? Now, it's not, I think it is loading the whole thing. So we've got starting from 11/15/2011, and how many days is this? So we're looking at just over a month's worth of tick data. Okay, that's quite a bit. But when you look at everything, you got a lot more data to work with, probably twice as much as compared to historical data. So there's some reasons for that. Now, let's be fair. Let me go back to the code here. Okay, we're just loading in a raw file. Okay, now typically I haven't seen the API for IQfeeds. There's probably a way where you can stream it in. You just connect into their servers and you can stream it in. So it'll be much faster there, and you can have a listener again do it in C++. I have to see the code, and I'll tell you this: I need to get permission from IQfeeds, because I don't think I can just publicly show IQfeeds code. I'm sure they're not going to allow that, and why would they? And I'm going to see if I can get a special permission to do some education around the API code for only, again, for my premium members. Now, because of that, I'm looking at probably another price increase, because it's a more bigger investment. I got to lay out $300 and da. But I mean, again, this sort of development is not for the cheap asses out there, as Microsoft refers to them as. Well, we won't use that word because you won't like it. But you will, like I've been saying all along for the last few weeks, that you got to put some investment into this now, because we're now getting into real world market data, and HFT. I've done some postings on it where I've got one posting about how already the source code that I'm showing and have access to is going to probably save any high-end company out there, hedge fund or whatever it is, just alone. And we're just talking in in licensing, commercial licensing software. We're going to save them at least $450,000. I've got a posting that's calculated on that, and to break it down for you in this video, it's roughly, with Redis demos that I've shown, that right there is probably a $250,000 implementation for what you would want to do properly in KDB. And also with Redis, that's open source, it's free. I've shown how fast that is. It's pretty impressive. Not only that, there's also the R itself with the clustering. I'm going to estimate that can be around $100,000 with the licensing for all the workers and all that. That's where they make their big money. Because right here in this video I've shown in R, again open source. And the third one, which is probably the most valuable, I've seen some commercial entities wanting to work with, if you do plan to go direct market access, which is a very expensive game, with the 5 major markets, be them Batch, DirectEdge, Arca, Itch, and I'm sure I've forgotten another one. Those source code options for the APIs for those on the commercial side is about $25,000 each for each market. Now I've got access to open source coding samples of that, and again, you're free. So right there, that right there is $125,000. So you got $125,000 for the market data feed source code for about 5 of them. You've got $100,000 for MATLAB, and then as I said, you've got the typical KDB implementation of $250,000. And lo and behold, if you can't afford $300 for an API key or access for IQfeed, if you cannot afford my membership, I really think, I always say this, go to a casino, bet your money, you're going to do much better than this stuff. And that's it. And that's why these guys are being paid $200,000, $300,000. Now they're just being paid for one function, but with this stuff you're getting the whole gamut of everything, which is good. Hopefully this video has demonstrated the capabilities real-world market data in a C++ application, and integrating it with an R call, doing like a simple R calculation, a differentiation, or calculating the returns, closing price or bid price, and return it back to C++ and see how long it takes to run. And again, I also should say we are running this in Ubuntu, virtualized on an i7. So again, remember we're using Armadillo, Rcpp Armadillo. If we recoded this in Rcpp eigen, we can right there save about 25% time, or shave off 25%. Also, if we ran this on a dedicated Linux box, not virtualized, you probably save some time there. And we're also running it through the through an IDE, NetBeans. So I'm sure we could probably knock it down, maybe for sure at least 25%, maybe half, who knows. So it's pretty good. And again, those sizes are just over 1 million observations. That's pretty cool. Again, I'm hoping this video just demonstrates everything. Again, for the source code, the files, all the education's in the premium membership. That's all I could say for Quant Lab users. I'll talk to you later.